we are asked to find the domain of this function given here. Now this function can actually be divided into two different parts in order to find its domain based on two different and important conditions here. First condition is based on this thing, this under root quantity, and the second condition is based on this log value. Now first thing is, I know that any real thing to be defined, anything inside the principal square root should always be positive, should always be actually non-negative, including 0, because even 0 is allowed here. So I can say that this quantity inside the root should be greater than or equal to 0. Actually, let me use the same color. This should be greater than or equal to 0. And secondly, the log value here, we have the log of x minus 1. This is actually log to the base 10 here, so we don't have to worry about the base. This x minus 1, this x minus 1 should be greater than 0. This is the second conditions. Now based on whatever values of x that we are getting from this first condition and this second condition, we need to find those x values which will together satisfy both the condition. I mean the intersection of both the x values, the intersection of the values which will satisfy both the conditions will be my domain of this function. So let us first of all solve them one by one. So if x times 3 minus x is greater than or equal to 0, this means that, let us draw a number line, let this point be 0. Actually this x can be written down as x minus 0, and here we have 3 minus x, and actually in order to make it a bit simpler, what we can do, we can write it as x minus 0. We'll put out a negative out, and this becomes x minus 3 greater than equal to 0. Now if I'll multiply with a negative both the sides, my sign will get reversed, but I can remove this negative sign from here. So this becomes x minus 0 times x minus 3 less than equal to 0. So this is what I actually need. So let me draw a number line now. This is my 0, this is my 3. Now I want x values which when multiplied together will give me lesser than 0, that is negative values. Now consider some values greater than 3, let's say 4 or 5. So 4 minus 0 is positive, 4 minus 3 is again positive. So it will never ever be negative. So I won't be accepting this one. The values beyond 3, I won't be accepting that. So this is gone. Let's consider the values between 0 and 3. Let's take for example 2. So 2 minus 0 is 2. 2 minus 3 is negative 1. So positive times negative will give me negative, which is what I require. So I'll consider values between 0 and 3. But what about values lesser than 0? Let's say for example negative 1. So negative 1 minus 0 is negative 1. Times negative 1 minus negative 3 is negative 4. So negative 1 multiplied by negative 4 will give me positive values. So I won't accept values below 0 as well. So from this condition, I found that x belongs to 0, 2, 3, including 0 and 3, because at 0 and 3, this whole thing will become 0, which is anyways acceptable. Now let us move on to the second condition. So x minus 1 is greater than 0. This means x is greater than 1. Now if I want to take the intersection of this condition and this condition, let's say this one will lie somewhat here. So according to this condition, these are the values that will satisfy the second condition. But since I need the intersection, so I'll take only the values which come under, which satisfy both the condition, that is this part only, the values between 1 and 3. So x belongs to, will include 1 or not? No, we won't include 1 because x is greater than 1. It is not equal to 1. So this will be 1 with an open bracket up to 3. But can we include 3? Yes, we can, because x is greater than 1 according to this condition. And if I'll substitute 3 here, this will be defined because this will become 0. So I'll put a 3 with including 3, a closed bracket at 3. So this is the domain of the given function written down here.